We started last week with the discussion of traps and vents, and I have a limited amount of time, so I didn't get into it too much. But I thought what I would do is kind of go over some old stuff and also show you guys some things that plumbers are doing. And some of the stuff is helpful to you because when you tell someone they got a problem, a lot of times, it can sound like a really big deal. And today we've got some options and for replacing traps and things like that. And I wanted to kind of go over it with you. For those of you that live in older communities, you might find in a basement or somewhere an old a whole house trap. I live in Virginia Beach. Things are fairly new here, in the scheme of things. So I don't actually see these too much. But anyway, the image that I have up in the upper left-hand side there is an actual one that's on someone's house, and the image below kind of covers it. If you pay attention to it, you see the water would be flowing in this direction, and you can see off to the right on the illustration down at the bottom. There's where the sewer gas is. Well, without that trap and that trap full of water, sewer gas could migrate into the house. In older times, that seemed to be the main concern. They would put a trap on the whole house so that they could keep that sewer gas from working into the house. This thing could actually vent. You can see air can flow through here. It's good for both when the drains are draining. It also helps air out the system and so forth. But what we ended up with is, for instance, on the whole house trap, the whole idea behind plumbing is to prevent, sewer gases and things from getting in the house, and to create a sanitary system so that we, don't end up contaminating things. And so we, not just with gases, but the sewage itself. These whole house traps could actually create some problems. The one on my illustration, you see it down in the hole like that. Well, these things get stopped up, and you're down there reaching down in that hole trying to break those clean outs off, and you'll find that hole is really contaminated. There's sewage is going to have gone in there at some point, and you get your hands in there, you get to work, and you could end up with an infection and so forth. So that's one of the problems with whole house traps. And we kind of changed our thinking and focused more on better traps, individual traps. And we learned a lot about trapping since, we started doing this. Also, if you look at the cleanouts on top of that illustration, that's considered a mechanical means of closing up the trap. And you could actually, on that right side where you see the gases, if the cleanout plug is loose on that right side, sewer gas could enter the house. So one of the things that we try not to do when we design traps is fix it so that there has a mechanical means to seal it up, that it requires this means to seal it up. You want the water to take care of the job. That's why when we put cleanouts in traps, they tend to be on the bottom of the trap. So anyway, that's the whole house stuff. I know probably a few of you may have run across these in when you're inspecting, you get up in New England and stuff like that, you'll see something from time to time. But in other places, don't see it. But the main thing to take from this is we went from the idea of trapping the house to focusing on the individual fixtures. There's a lot of traps, guys. This is I got some 100-year-old books here on plumbing, and that's just one collection from this guy's images that he had on showing you different types of traps. And they tried a lot of different things. If you pay real close attention, you'll notice one of the ideas was to create a huge reservoir of water. They knew that if they could collect a lot of water, the likelihood of it evaporating and allowing sewer gases into the house was, not so great. So they did this initially. Well, what they ended up doing in many cases was they created containers that ended up having sumps. If you look at this one, this is one from an actual job. And if you pay close attention to it, the water is going to stay that high in the trap, but at the very bottom, it's created a sump. So you get stuff down into the trap, it's going to get in there. It's going to be hard to get it out. It's going to be difficult to clean it. And so you might be able to fill something up like that with water and keep the sewer gas out of the house, but it's going to be getting stopped up a lot. And so, that's going to probably create more of a headache than worrying about the sewer gas. A lot of sinks we run every day, they basically get reprimed. But if you have a drain that's constantly clogging up, and depending on what you're putting down that drain, obviously it's going to be a pain for you. So we started looking at things with, different ideas and focused more on better venting for individual fixtures and better traps for individual fixtures. I may have read this last month, but what we're trying to do with the trap is it needs to be non-siphonable. Now, an S trap is a trap that tends to siphon by momentum. So that's one of the reasons why an S trap is not really a very good trap. Self-scouring. The water should actually flow through the trap in such a way it kind of scrubs it a little bit as it flows through. No internal partitions, no mechanical devices to form the seal. I just mentioned that a minute ago with the caps or the clean outs on the top. That's a mechanical device and it helps form the seal. So we don't want to do that. As few corners as possible, sharp edges. You've got 90-degree, hard 90-degree turns and so forth. Again, more prone to plug up. Of course, you want it to contain sufficient water to prevent evaporation. And that's kind of difficult because if you build the trap too big, then again, you end up with, like I mentioned a while ago, you end up with sumps and things like that. So the overall design on a trap, it can evaporate. It would take a week or so in most cases. We get situations as plumbers where families will move out of a house, or let's say it like this. Let's say mom, dad, and a whole bunch of people living in the house, kids and all, and the kids go off to college. When these bathrooms that the kids were using are no longer being used, the water in the trap evaporates and you get the sewer gas in the house. So that's just from evaporation. It's hard to prevent it. You have to go in and periodically run some water, flush the toilet, run a little water down the fixtures, and that'll take care of the problem. In many cases, they don't realize that that's a situation. So I've gone into houses before where you've got smells in the house. People can't figure out what's going on, and then when you show them, it's just a matter of running water once a week. They're happy, except they don't like the bill. But anyway, offer the least resistance to the flow of water. Again, sharp corners, things like that are going to be a problem, and an accessible clean out, preferably below the seal. And a lot of our traps, the tubular traps, it's not necessarily going to be a clean out. You just take the trap apart. You break the slip nuts loose. You can take the trap apart, and those are fine. Plugging the bottom is fine as well. But if you can do that, take the trap apart, it's essentially a clean out. So it's easy to actually snake the entire line out if you can open that. This is a trap that we call them Richmond traps around here. I'm not sure if there's another name for them, but you can see sharp edges. There's a brass plug in the bottom of this thing, and I think I've mentioned this to some of you guys before. Next year will be 50 years in the plumbing business, and I've never been able to get one of those plugs out of that trap the entire time. Anytime I've ever tried, I ended up just taking the trap loose and disconnecting it, throwing it away or whatever. But these traps are a pain. You can almost never get a snake to go around it. It'll go in the bottom and kind of curl up. It'll run around in the bottom, but it rarely wants to turn and then go up, up the drain and into that elbow. So it can be a real pain to deal with. What a lot of guys do is they'll cut the pipe, they'll cut the trap out. Now this isn't the same house, but it's more than likely that's what they did here. They cut the line, they used a no-hub band or a Franco coupling, and they just put a regular P-trap in there. And I guarantee you that line stayed so much cleaner and flowed so much better, than it did before. It looks like they got a little carried away with their primer, but anyway, that's just a standard P-trap, and it's pretty easy to replace these, especially on galvanized steel, cast iron, of course, PVC and stuff like that is just a given. The plastic pipe is just way easier to work with. I just threw a few pictures in here of some crazy looking traps that you don't generally run into, but this one I pulled off of one of the plumbing sites that I go to. Here's another one. It's pretty crazy looking. What we do see a lot of is bottle traps and variations of bottle traps. That trap can go really close to the wall. And a lot of times on pedestal lavatories, the problem you have is the line comes out of the wall and you use a regular P-trap and the line is too far forward and it makes it difficult to connect. Now, the trick to that as a plumber in many cases is you rough it off to the side or something like that, and you can kind of come at it at a little different angle. But again, these traps they've got a partition inside of them. And one of the things I mentioned a while ago is if it has a partition, you're not supposed to have that type of trap. I do see them pop up all the time. I explain to people how they work, and I explain to them that they can fail and you not even be aware that they fail. Here's what it looks like. Here's your sink above, the line will be coming down from a pop-up or from a basket strainer. It'll go into the drain. And then there's a partition inside this device. And the partition, when you put water in it, the partition is kind of right down the middle. So if that opening at the top has the pop-up or the PO plug or whatever stuck down inside of it, the water will go into the one side and it'll have to go down below the partition and come up and over. Here's the problem though. The partition can break off. If the partition breaks off or it gets a hole in it above the water, what you end up with then is, let's say the partition broke off, you would have that, and now sewer gases can come on into the house. So you may or may not see these in the field because many areas just say, no, we don't want you to use them because they don't follow good trap design. But I'm sure we all know that the do-it-yourselfers are out here, the flippers, and they just assume that if you can buy it, it's legal. And of course, that's not the case. I mean, I even see ball cocks that they sell that aren't even legal today. So anyway, that's the bottle type trap. Sometimes they just look like a big round trap at the bottom, and there's a pipe that extends right in the center of it, and that's essentially the same process that they use inside that trap. But here's our favorite old S trap. They're super popular. They've been out there forever. Almost every plumbing company has a picture of one on the side of their truck. And the problem with these things is they're prone to siphoning. Water will be dumped from the sink. It'll go in, it'll pull the drain, and now you've got sewer gases that can come into the house. I always found that when I would tell the people as a plumber that this is going to be a problematic drain for you, it's going to let sewer gas come in the house, they would always go over, fill up the sink, pull the plug, and just try to explain to me, look how fast this thing drains. And what you have to get them to understand is it drains too fast. It actually drains so fast, the momentum of the water will siphon it down. So if you've got a drain coming up in the bottom of a cabinet, and with an S-trap design, for a while you basically had to really do some major work in order to correct that. But with AAVs, air admittance valves, it eliminates some of the headaches. We can actually remove portion of the trap, the top portion of the trap, and then you might have to move the drain slightly to the left, to the right, or out. But if you can move it a little bit, offset it a little bit, now you can put a T in that pipe and an elbow, and on the top of a small section of pipe, you can put an AAV. Now, what you end up with is, you're going to have a small section of pipe in there. You can't take that elbow and push it into that T. If you take the elbow and push it tight up against the T, what's going to happen is it's still going to create that S-trap type action. The AAV might help it a little bit, but just giving it a little bit of distance. Some people will tell you, twice the diameter of the pipe. But if you get a little distance there and have the AAV on the top, it's a fairly simple repair if the people are concerned with it. A lot of times as a home inspector, I would just tell people, hey, they're getting ready to buy a house. You would talk to them if they were going to do remodeling on the house. You would explain the situation, tell them what the concern is, tell them what the concern is with sewer gas and so forth, and tell them to be sure that that gets taken care of. But if they weren't, then I tell them to get a qualified plumber that understands how to do this little trick, and then that can, again, it's not, totally inexpensive, but it's nowhere near as expensive as it used to be. Here's what this is brand new construction, and this is where one is installed. Basically, it comes up into the bottom of the cabinet, and you see the AAV in the back there. Now, an AAV is a little different than the old inline vents. You might remember the old inline vents. That's that guy right there. An AAV works a little different. The way it works is when the drain is running and it's trying to pull a vacuum on the line, the AAV, it channels that vacuum to the top of the device and it lifts it up, and it just allows it to break the vacuum, and it does that pretty easily. Under pressure, it actually seals tighter. It'll seal tighter. So that's why you don't have to have this up so high. Whereas if you did the old inline vent, like you see there on the left, on an old inline vent, if you didn't run that all the way up under the sink as high as you could get it, it would almost always leak. We would put them on wash machines, and if they just over soaked a load of clothes, there would be bubbles coming out of it. Here's the thing: when they first were introduced, a lot of them said Boca approved. Right on, had a red sticker on the thing, said Boca approved, so everybody assumed that they were okay. They gave us some options, but they really weren't all that. I mean, they didn't work well. The gaskets wore out. Whereas the AAVs hold up really well. Some of them have a lifetime warranty on them. They seal pretty good. A little more expensive, certainly more expensive than the inline vent. I mean,
hey Kenny, we got a question here from Anatole. He's talking about cleanouts. And he's wanting to know about why and when do we use cleanouts, specifically when there's, say, when you got a drain coming in at greater than 45 degrees. What's the deal there?
Well, for a long time, if you had one greater than a 45 degree, I'm not sure exactly where he's talking about the particular drain, but for years, let's say out in the front yard, you got a line out or under the house. It used to be every time you made a 90-degree turn, whether it was with 245s or a 90, you had to put a clean out in the end of it, because years ago we used push tapes to unclog the drains. Today, guys, I got to be honest with you, these sewer snakes that we have today, the Spartan snakes and pressure washers and stuff like that, some of those things will go around a hard 90. I mean, these things are amazing compared to what they used to be. But, for years, anytime at the base of every stack, you were supposed to have a clean out. Every time you made a 90-degree turn, whether it was 245s or hard 90, you had to put a clean out. And again, I don't get as worked up on modern plumbing as I used to, back in the day, because we just don't use the same equipment. We run a snake that the things, most of them that come from the factory today can bend very well. And again, some of them are pressure jets and so forth. So usually the base of the stack, hard 90s, things like that. And then out in the yard, it would be every so many feet. Depending on the locality, it might be every 50 feet. The reason for that was because the snakes that we unrolled, the push tapes that we used, they would come in like 50 and 100-foot sections. So we had to have a clean out close enough so that if it didn't quite make it, we could do it again. Now, I actually just ran into a problem in my own house. I had the flu a week or two ago, and we ended up with a drain stopped up. It stayed stopped up for 2 days because I was so sick I couldn't get outside and work on it. And I did get a guy to come over and get up on the roof, and I had one of those old push tapes. And I was able to kind of figure where the stoppage was, and it was actually in the stack, right below a T where the two toilets came into. And he was able to push that hard snake straight down the drain and hit the blockage. It was just overloaded with paper, and he was able to push that through and break it loose. And I was out in the yard, and I was able to look through a two-way clean out. It was very shallow. My dad put this in years and years ago. I was able to see it break loose and go by. Those things were great for like cleaning main drains, but they were very difficult to get around other drains where a lot of turns and stuff. So like I said, the snakes have changed a lot. Some of them are amazing. We have all kinds of heads that we can put on them. One of the hardest things to get to a snake to do sometimes is you want it to go down and it wants to go up. On an old system, it might go up. It might actually run up. But on a newer system, the slope of the T will usually direct it the way you want it to go, or the slope of the combination. And the head of the snake, we put a drop head on it, so gravity keeps pulling it down. And when it goes into a T, it drops down into the run of the T, and it can able go in the direction you want. So a lot of it has to do with older stuff, and I'm sure that's mainly why you're seeing the older ones.
Okay, so we got another question here, Kenny. I think this person's just wanting to differentiate between an S trap and a P trap. It's the length of the arm, right? What's that?
Yeah, that's the main thing. Let me see if I can back up. See that right there? If you push that elbow right up against that T, you've still effectively got an S trap. Because the drain will just come over there. Once you level it out, and then of course you put that AAV on the top of there. As the water goes around the trap, comes over the wear of the trap, and it flows a little bit, drops down into that T. You might be able to create a vacuum, but the AAV will open up. The AAV will open it up, and it'll break that. Whereas if it's jammed up against the T, the water may just go around it, and it just by momentum, it's going to overpower the drain. So basically, you got to have a little length on the arm, and in the length of the arm, a lot of people don't realize it is determined because you can only go so many feet with the length of the arm and still allow air to come in from the T and get above the water. So that's why you're on an 1.5 inch pipe, you might be limited to 5 feet on the arm or something like that. It's because if you put the normal slope on it, if you go 15 feet, you're going to be so high, you're never going to get water from the T into that pipe above the trap, and it's always going to siphon. So anyway, the advantages of AAVs, I'm a big fan. They were used in Europe a long time. A lot of you might even hear them called Studer vents. I think that's German. They were introduced a long time ago. A lot of the stuff came from things like in Scandinavian countries and stuff, where vents on the outside of the house became a problem because they would get filled with snow and ice. So they could put these things in the house, and that enabled you to not have the problems with them getting clogged up. It saves on piping, on material, and especially installation costs. The device itself might cost $25. And on a bigger one, it's going to cost even more than that. But here's the thing. You're going to save so much labor time, and that's where your money is on plumbing, is in the labor. You're going to save so much money. A guy going from the first floor through the roof with a vent, he's going to have to do all this drilling. He's going to have to use all this pipe. It's going to take a long time to get there. It does things like provides greater freedom for designs, for engineers and stuff. And this main thing that we think about there is islands. AAVs allow us to put islands just about anywhere. In the past, you had to have something kind of near a wall somewhere so you could get a vent into the wall, unless you wanted to build some fake wall, and it kind of took away from the appearance. So an island, an AAV can, take care of that problem. You're going to eliminate roof penetrations by doing this. You're going to have one vent through the roof, even with an AAV. Have to have one vent to go through the roof, but most of the other ones can be under the sinks. They can be in the wall above a wash machine, or they can terminate in the attic, as long as they're not terminating where they, can get covered up by insulation and they're not being seen. So we know that a lot of things poking through the roof are going to be more prone, to causing a roof leak. So, you're able to do that. It reduces the need for fire stopping. When you start drilling the houses up, you got a chance of a fire going from the first floor to the roof real quick as this stuff starts melting and collapsing, and you know, everybody knows plumbers get a little carried away with the Sawzall. So that kind of helps you with eliminate a lot of that as well. Requires no maintenance. There's nothing to fix. If you do find one that's gone bad, you smell sewer gas coming out of it and something's broken with it, you just toss it. You just get another one and screw it in. But again, many of them are basically said, you know, they'll last a lifetime. They'll take care of it. Easy to install, doesn't require skilled labor, and that's good. You know, I always make a joke with my HVAC students. I always tell them if they don't make it, I'm going to send them to plumbing class. And it's because plumbing typically is easier, you know, and we have this running joke about that. The trades kind of, you know, battle each other, but it doesn't require a lot. I mean, a lot of plumbing is just good, hard bull work. You know, once you get some of the basics down, you can put a guy to work, you know, pretty quickly. It can be retrofitted into an existing drain. That's like I just showed you with the line under the sink, you know, for removing that S trap and putting a P trap in there. It can be, you know, it can just be added to that. It can eliminate this. A lot of people say, well, you know, I'd rather have an island vent. I got to be honest with you guys, island vents suck. Now that's the problem with them. They do suck sometimes. They are noisy in many cases. You'll let the drain go out and it'll just make, you know, it'll make a racket. And one of the problems I always had with them, see the pipe here marked vent? All right, when you get a blockage in that line down there where it says family handyman, you can get debris to back up in that pipe. The sink's not going to drain. And sometimes that debris will get pushed into that pipe that says vent. That pipe is flat or pretty close to being flat. The problem with that is when it unstops and everything begins to flow, you still might have a blockage in the pipe that says vent. On other plumbing in a house, when we run into that situation, we can't just run a vent like that, a dry vent. If you want to run a dry vent where it goes up in the wall somewhere, you got to have another fixture attached to it to keep it washed out, or at least identify that there's a problem. If you pull the plug on a sink and it doesn't go down, and let's say it was connected to that vent line that goes up in the wall somewhere, well, we would snake it out to get the drain to work, and that would open the vent back up. But the way this thing is set up right here, it may get blocked up the first day it's put in and never be open. And I've just found over the years, they're kind of a pain. People tend to not know how to put them in. I see some crazy configurations where people were trying to put them in, and it's just so much easier to just have the pipe on the right side there, just come up like it is and just put an AV on the top of that. And I don't see nowhere near the concerns with them. I hear some people freak out about them. And you go into other parts of the country and people are always assuming that if it's harder, it's better. That's not the case, guys. I'm telling you, it's just, you know, there's still places that are using cast iron and galvanized steel and things like that. And I would stake my reputation on the fact that PVC pipe is the best thing that ever happened to plumbing. It doesn't stop up as much. It's easier to put in. It'll probably help extend the life of some plumbers, because I mean, I'm in my 60s and I am broken down from all the years that I load pipe and did this type of work. Real quickly, if you go into a house and you realize they do have AAVs, pay close attention. Sometimes you'll look under the sink and there is no AAV. The pipe has got a female adapter on it or something, and there's nothing in it. So you want to make sure that if they're missing, they get put in. Sometimes they're plugged. Now, usually they're plugged because when they were getting the test on new construction, you take the AAVs out, you plug the openings where you're going to put the AAVs, and then you flood the system. You fill the system up to a level above the roof. So you got to have all these things plugged. And then when they go back to getting, to reactivate the system, they forget to take some of the plugs out and put the AAVs in there. You've all probably been on a roof and found a vent pipe capped. It's usually on a lower vent pipe because they cap it so when they do the flood test, they get the water to go up to the highest vent on the roof so they can get some water in there for testing. If it gets covered, normally what we're talking about there, I have seen them in walls, but generally speaking, what I'm talking about there is in an attic. When it was in the attic originally, there was no insulation, and then the guy came in there and he put 2 feet of insulation in. And sometimes you can actually see where the insulation's falling into the pipe. So make sure you kind of look around if you know they're using AVs. So you may be able to spot one that's just covered by insulation. They need to be positioned upright. You know, you
Hey,
don't
Kenny,
put 'em-
can you put one on a on a clothes washer standpipe?
you can put it on the vent, yeah,
Yeah, okay.
not on the standpipe.
Not on the pipe itself,
No,
obviously,
not
because
on
you
the
got to.
standpipe. No, the standpipe has got to be a standpipe. A lot of people think there's an air gap. That's actually an air break. The hose hangs into it, and it goes down the standpipe through the trap and over to the vent. Now you can most of the time if you see one on that, what they'll do is they'll open the wall up, a foot or so, maybe 2 feet above the washing machine. They'll put a little grill in the walls in a box, and they'll put that AAV in the box in there because wash machines discharge pretty hard, and that way, if you got it up high enough, there's almost no chance of you getting water coming out of it. But yeah, it's pretty common to use them. That flat trap I showed you guys earlier, I have probably cut out hundreds of those things over the years on washing machines. And we used to put the inline vents in there, but we would run it way up high. Well, now I can just run it up a couple of feet or a few feet up. I usually get it above the wash machine and just put an AAV on it, and it's usually fine. And I'll tell you another thing: let's say you come up a foot or so above the wash machine, it's a great place for a clean out. You can unscrew the AAV, and you can have your drain machine right there, and just run it down where the AAV was. You just unscrew it and run that snake right down through there, and it keeps you from having to go on the roof and run the vent, and it keeps you from having to move the washing machine out in many cases and try to get to a clean out behind the wash machine. That's a pain in the butt for plumbers to have to drag the machines out, disconnect the hoses, do all that stuff. And anytime you ever do that, you end up likely breaking a hose or something. So it definitely works pretty good that way. Insect block is not so much, but I mean, I had one guy tell me he saw some mud daubers getting in. I've never seen that, but I put it in here just in case if you do see one in an area, because every now and then there's things that pop up on us. You're like, I never thought I would see that. For instance, on intakes on direct vent furnaces, I never thought I would see this, but we started noticing on the intake at the inducer, we were getting moths. And then we realized what was happening is on the intake outside the house, the intake vent was near a floodlight. And so the moths would be, flapping around by this open vent pipe, and it would suck them into the pipe. So, things like that pop up that you've never had happen to you before. And you're like, hey, I learn something new every day. So that's this, things just happen like that. This is a question I get a lot. I'm about ready to wrap up here, but this is a question I get a lot. Can you put the vent on a receiver for a sewage lift pump, or a pump? Like a lot of us have pumps in the basement. Around here, we don't have too many basements. We actually have them in front yards sometimes. And here's the thing: an AAV or an inline vent is not supposed to be installed on a receiver. Inline vent will probably leak enough gas out that you're going to smell it in the house. When the sewage is running into the receiver, it can put enough pressure on it that it'll flatten the diaphragm in it. And on an AAV, the other type, when the water's coming into the receiver, the AAV doesn't vent; it shuts off. It shuts off under pressure. So you really need to have these, they need to be vented to the outside or tied into the plumbing somewhere. You can tie them into a plumbing drain, away from the discharge or something like that. Get away with it. There are some engineered systems where you might see one, but if I try to get into that, you probably never see it. But there are occasionally some engineered systems where they might use that.
So can you put them behind the wall covering, or do they have to be accessible?
Got to be accessible.
Yeah.
Yeah. Most of them, what they'll do is it'll look like you buy a box, kind of like the washing machine box, or you buy the ice maker box. They have the boxes like that with a grill in them, so that it needs to breathe a little bit, and then it needs to be accessible. The chances are, if you were looking at let's say you're looking at a wash machine on a single story house, and you thought, well, it needs to have an AAV on it. Maybe they ran it up into the attic. Well, by the time you do the attic inspection, you might forget it. And so you're in the attic and you completely forget about it. So it could be in the wall. If it's in the wall, then, at some point, if they ever have a drain problem, a plumber might figure out something's going on. But you know, it's just the way it is. I can tell you guys, I've done commercial work before and watched plumbers actually reach down in a block wall where they laid blocks and so forth. I've seen them actually reach down in the wall where the vent pipe was coming up and just put a cap on it. They didn't want to run the pipe. They didn't want to run it up the rest of the way up the wall and run it anywhere. And they were just basically hoping nobody was paying attention. And if nobody was paying attention, they slap a little glue on that cap and stick it right down on the wall and cap it off. So, you know, it's unfortunate, but you know, every trade's got somebody like that. So